All right, so we are recording the simulation for lesson 1. You should have already done your attendance, your bell ringer. We just watched this video from TED Ed, and then we're going to go through this Google Doc that matches up with this PhET simulation that's embedded in your lesson here. So let's see what questions we have to answer. The first question, what can you change about the simulation? We'll have to look at that. Let's go ahead and look at it. Sometimes. If we look, this is the first thing that you should come to when you go into the introduction. Notice you have tools here. The first tool, you can pick none, but you can also pick the balance beam or the bar graph. And so either one will work for you. Notice they're all at 0. If we change those coefficients, that's when we get some real data and numbers that we can use. How many of you remember balancing chemical equations from some other class that you've had before? You know that you probably did it in 8th grade, probably. Hey, guys, if you're on your phone, you're not paying attention. So, okay, so you probably do remember that from some other class, but let's kind of review. These big numbers here are called coefficients. These little numbers are called subscripts. Notice I cannot change the subscripts. Why do you think that is? Well, if we change the subscript, we would have a different molecule. But if we change the coefficient, what does that do? It gives me a different number, in this case of the molecule. In an actual reaction, that would tell me the number of moles that I need. So right now I have 3 molecules. That's at a molecular level. In the actual, real world level, these coefficients tell us the number of moles that we need. So we're going to need to kind of keep that in our minds as we go through this unit. All right, so I'm looking at this. What is the point? I have 2 blue spheres here and the reactant side and the left side of the reaction. But on the right side and the product side, I only have 1. What happened to the other one? Well, that is the whole purpose of balancing chemical equations, is that we need to show what happened to all of the atoms and all of the moles of atoms that we started with. So now I have increased my coefficient to 2 on the ammonia that I'm creating. I have 2 of the blue spheres and 2 of the blue spheres. I have 2 on each side. 2 atoms of nitrogen in the reactants right here, and 2 atoms of nitrogen in the products over here. Okay. I need to make sure if I'm looking at my reactants and my products, now I have 6 hydrogen atoms. Where'd they all come from? They have to come from somewhere. So that means I need to show that in my chemical reaction. So I can see that I would need 3 molecules of hydrogen gas in order to make 2 molecules of ammonia. So that's the whole point of these coefficients, is we have to show where did our atoms come from and where did our atoms go, because matter cannot be created or destroyed. And that is the conservation of matter, or conservation of mass law that we have to show when we balance chemical equations. All right, so we've kind of seen part of this. Let's go back and look at our questions. What can you change about the simulation? You probably could answer something right there. You can change the tools that you're using. You can change the coefficients, right? You can probably go ahead and answer the next 2 as well. Describe in your own words the purpose of the balance scales and bar charts. So we kind of saw that. And how do you know if you have balanced the equation? Go ahead and answer those 3 questions. I'll kind of review that part here. If we look at the balance in the bar graph, it shows us how many atoms that we have on the reactants and the product side. So that's kind of the purpose. And I'll let you answer those. So take a couple seconds to answer those, and then we'll come back together. All right, so the next questions, you should have answered up to 3. The next questions give you this data table. You see an action, so it tells you what it's doing, the equation, particle view. You don't actually have to do this. It'd be way easier if you were drawing it. So we're just going to put in there, you can leave this part blank. But then the steps you took, I want you to describe what happened in order for you to make that equation balance. So let's go back and look. We already did the make ammonia one because make ammonia is this part. So what you would put is the coefficients that you had, and you can leave ones blank if you want because they can be invisible, but the rest of them you need. So let's go ahead and fill those in. 1, 3, 2. I don't care if you put the 1 or not, but most people would say make it invisible. That's up to you. But then over here, that might be kind of hard to come up with. So let's go back and think, what should we put there? Well, we saw that we only had 1 nitrogen in the product, so we had to show where the other one went to. That might be something. Well, it might help if I could type too. So something like that. Let's go ahead and the next one we're going to do is separate water. So if we go back to the lesson, see this ribbon here tells us separate water. To always start with that invisible 1 so that we have something to look at. And then what do you notice before we even look at it? What do you notice is different about this equation? Say that again. What does that mean? Okay, so the one before we had 2 things that made 1. So make ammonia, we took 2 single elements and made 1. That's called synthesis or combination reaction. All right, what about this one? We only have, he says flip-flop. We only have 1 thing and it's kind of fallen apart. Okay, that's a really good observation. This is called decomposition. And so we're going to learn those reaction types as we go along. But what is the first thing you notice when you're trying to balance this one? It's really easy to look at it and see, well, there's red spheres, 2 red spheres in the product side and only 1 red sphere in the reactant side. So I need to make 2. Now, you're not always going to have this picture though. So one way to look at that is when you take the coefficient times the subscript, 2 times 2, that gives me 4 hydrogens, and that's our number there. 2 times 1 gives me 2 oxygens, and there's those red spheres. Over on the product side, I just had invisible 1 times the 2 of the subscript. That gave me my 2 oxygens. So we're going to have to make sure and remember how to do the math for those as well. But we're still not balanced. What do we need? We need 2 more hydrogen. I can't change my subscript, so I have to change my coefficient. 2 times 2, that gives me the 4 hydrogen that I need. And this makes it super easy because we can see it, but also realizing that coefficient changes the number of molecules or the number of moles that I'm going to use in my reaction. All right, so 2, 2, 1, that's what we're going to put in our All right, so we said we could leave this one blank, but steps you took to make the balance equation in balance. What did you notice? You needed more oxygen in the reactants. And that's just a simple statement on those. Is fine enough. All right. The next one says combust methane. What do you think of when you think of the word combust? Yeah, I think of an explosion too, a great big fireball. So when I think about that fireball, let's look at the equation that it takes to combust the methane. you just said you thought of a fireball, and here's my reactant. So carbon, wood's based in carbon. There's a lot of things. This is actually methane. So this is a gas. This is oxygen. Wait a minute. If this is combustion and we have methane and oxygen and that makes carbon dioxide, okay, that makes sense. But it also makes water. That's a really important observation. I thought we put fires out with water. We do, but water, H2O, is still a product of combustion reactions. So we want to make sure, even though it's kind of an oxymoron sort of situation, it is a product. So whenever you have combustion of a hydrocarbon, which we'll talk about in this unit later on, you're going to have carbon dioxide and water as your product. So it's a really important one to kind of make that observation with. All right. Usually we would start with carbon to balance, but in this case, carbon matches. So we're just going to go to hydrogen. We have 4 hydrogens, 1, 2, 3, 4. This coefficient times the subscript gives us 4, and we see that in our bar graph, so it makes it super easy for us. But we only have 2 hydrogens in the product. So increase that. All right, now we have 1 carbon, 4 hydrogens. We have too many oxygens on the product side. We need to increase the oxygen on the reactant side. Okay, now one thing I want you to really remember, we get the happy face so we know it's good, but in your head, you are recounting every time you change a number, but you can do it visually with this box. When you don't have the box, when you're just doing them on paper, like later on next week, you're going to have to use the math. So 2 times 2 is 4, and that recounting you're doing subconsciously right now because you can see it. But you want to make sure that you're aware that you are doing that every time. All right, so combusting methane, we had 1, 2, 1, 2. That's convenient. 1, 2, 1, 2, and then you can leave that middle one blank. And what did you have to do? We had to make the hydrogen match. Then we change the coefficient for the oxygen to make typing. Make it match. All right. So that's pretty straightforward. I think hopefully it kind of woke your memory up a little bit to balancing chemical equations, because I'm sure you have done it at some point in your life before. But let's go on. The next part, you're kind of thinking about those words. Make, separate, combust. We look at make ammonia. We had, like Cordell noticed, we had 2 elements that went together to make 1 compound. That's making. That's synthesis. That's combination. That's one kind of reaction. Separate water. We had 1 compound that fell apart to 2 smaller things, to 2 less complex things. And then the combusting, we talked about the fireball, what you would think when you think the word combust. Okay. And from the video earlier, sometimes you need a little extra energy. So you know that usually you need something to start it, to start a fire. So in that case, that'd be a spark. You need oxygen, a spark, and a fuel. Methane is the fuel in this case, and usually it's a hydrocarbon, which we'll talk about. So think about those words, answer the question, and then the game part, I'm kind of going a little fast because I am recording it, but the game part, I want you, if you look at your simulation, there's the go home, there's the introduction, and then there's the game. I want you to do all 3 levels, and I want you to get at least 12 out of 15 stars, okay? So what you do is you go in and you start it. It's exactly the same thing we just did. You're like, okay. There you go. Not balanced. Try again. All right, what did I do wrong? Don't let that mess with you there. So we had 1, 2, 3, 4 oxygens, 1, 2 carbons. We have 1, 2 carbons. Oh, wait. We have 4 carbons in the product side. So 1, 2, 3, 4 carbons. Now let's count them all again. 4 times 1 for carbon is 4. We have 4 carbons over here. 4 times 1 oxygen is 4. We have 2 times 2 oxygen is 4. So we should be good now. Now we get a balanced but not simplified. So we got no stars on that. But if you go on to, when you look at it now, they show you the simplify is to reduce it. So just be sure that you reduce your equations as you're moving along. Do another one just to redeem ourselves. All right, so they do take some thought. Okay, so we have 1 carbon. We have 1 carbon, 1, 1. Hydrogen, we have 1 times 3 plus 1, that's 4. We need more. 2 times 2 is 4, now we have 4. 1 times 1 oxygen. Okay, we got our gold star. Okay, so go through all 3 levels, try to get at least 12 out of the 15 stars, and then you will, I'm just asking you to record it this time, but I would like you to really try it because this is fundamental to being able to go through the next steps of this unit.